Hello everyone, I'm Yanzun. Today, Dongyang, Leyang, Chuankai and I will introduce our final project for interactive data science. Our project includes two parts. In the first part, we explore the relationship between shots in NBA and other interesting attributes. One of the datasets we use includes records of all shots in the 2014 to 2015 regular season. It has 21 separate attributes, including a few quantitative ones, like time on the shot clock, how many dribbles were taken, how long the player held the ball, distance from the goal, as well as the closest defender and the defender's name. It contains roughly 128,000 rows of data, of which we use roughly 122,000 after filtering out for null values. We picked 8 unique attributes and ran a covariance matrix between them to determine attribute interdependence. As a result of this analysis, we picked out 6 attributes that we believe would best help us answer the question, what influences shot making? In total, we ran 5 models using these 6 features to try and create a model that predicts shot mix. These 5 models include logistic regression, linear discriminant analysis, k-nearest neighbors, cart and knife Bayes. We held out 20% of the data as test data. The rest of the data was used as training data and tested using tenfold cross-validation. Of the models we tested, logistic regression managed to generate the highest test accuracy. LDA and knife Bayes did almost as well, while KNN and CART did not do well at all. We took a closer look at logistic regression, as that is the model that we believe performed the best. Looking at the coefficients, we can see that the shot clock, dribbles, and closest defender distance had a positive relationship with shot mix. That is to say, having more time on the shot clock, dribbling more before taking a shot, and the closest defender being farther away from the shooter means it is more likely that a player makes a shot. On the other hand, touch time and shot distance have a negative relationship with shot mix. Holding the ball longer and shooting from farther away makes it more likely for the shot to miss. All of these seem to match our assumptions and make sense from a logical point of view. But it is worth noting that none of these attributes seem to have a strong relationship with shot mix. As a result, this model only produced a test accuracy of 61%, which is only 10% higher than random chance. This was also the best performing model among the one we used, which seems to imply that none of these 5 factors have a strong effect on shot mix. It is worth noting, though, that the model was significantly better at predicting misses than mix. We do think there are reasons for this, however. For one, this model doesn't take into account who the shooter is and who is defending the shooter. These two are likely very strong factors in determining if a shot is made. However, turning these two attributes into categorical attributes would not help us answer the question of finding the general attribute that affects shot making. It will place more emphasis on the players. One possible way to modify this in the future is to separate the players out by position and create a categorical attribute from those values. There are likely also many other hidden attributes that can affect shot mix. Although our model only outperformed 10% the random chance, we can say that these attributes are able to quantify at least some of what leads to shot miss. Here comes the second part of the project. In this part, we explore the winning rate of each team in each year. This graph is a visualization of NBA teams' actual winning rate from 1986 to 2018. The team we are showing right now is Golden State Warriors. They achieved a winning rate of 89% in the year 2016, which is the highest of all time in NBA history. Let's also take a look at the winning rate of Cavaliers. We can see that their winning rate dropped from 74% in 2010 to 23% in 2011 due to LeBron James' leave for Miami Heat. These four graphs shows how the offensive efficiency and playing style affect winning rate. In these graphs, the larger the circle, the higher the winning rate. The first one represents the field goal accuracy and three-point accuracy. It tells us how efficient each team is in terms of offense. We can see that the teams with higher efficiency, which are the teams in the top right corner, tend to win more games. In addition, we can find that three-pointer accuracy is not as an important factor as field goal accuracy. This makes sense because some teams play more aggressively and don't rely on three-pointers to win, like Hawks and Lakers. The second, third, and fourth graph tells us about each team's playing style. In the second graph, we can see that each team that shares the ball, indicated by a higher assist-turnover ratio, tend to win more games. The third graph shows the relationship between defensive aggressiveness and win rate. Usually, when there are more steals, it means that the team is more likely to play physical defense, which leads to more fouls, and vice versa. Being more aggressive doesn't imply victory, though. Teams that defend conservatively may also win the game through their cautiousness, like San Antonio Spurs. The fourth graph, we can see the pace of each team. Teams like Warriors, who are on the top right corner, play quick basketball, whereas the teams like Grizzlies tend to slow their opponents down to their own rhythm. Predicting the win rate of a team in the upcoming year is a challenging but interesting task. In order to do so, we use the field goal accuracy, three-pointer accuracy, rebound, assists, blocks, steals, turnover, point gain, and point lose as features to train a neural network with 4 fully connected intermediate layers. For example, if we want to know the win rate of a team in year 2019, we train the neural network using the data in year 2015, 16, and 17 and predict the win rate with their data in 2018. The two graphs here shows the predicted and actual win rate of each team in season 1995 to 1996 and 2017 to 2018. We can see that we get decent prediction on teams like Miami Heat, Houston Rockets, Los Angeles Lakers, and so on. This table shows our predicted win rate for next season. The teams that are marked red are the teams that can make it to the playoffs. We'll be able to see how accurate they are by the end of next year. This concludes the presentation. Thank you very much for your time listening. If you have any further questions, please feel free to email us. Also, thank you very much for this amazing semester. We have learned a lot through this course.